lecture. So to summarize it, what we have right now is this. This is very important summarize that you can see from equation 17 and equation 18. And basically it say, if we want to calculate the intermediate vector f sub L corresponding to level L, that computation will require k index, where the index k is supposed to go from 0, 1, 2, blah, 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 all the way up to capital N minus 1. N minus 1. So, for example, when n equal to 16, that means the index k, it can go all the way from 0, 1, 2, up to 15. Okay? So, computation of the vector FL will involve with 16 component represented by the index k going from 0 to 15. And the formula, equation 17, say that to compute FLK, you just need the value of the same location k of the previous vector. The previous vector means at level L minus 1 plus some weighting factor equal to W raised to the power P. P, I will tell you how to figure that guy P later on. Multiply with the same previous vector L minus 1 at the location K plus N divided by 2 raised to the power L. Now, please remember the reason I say this is because the computation of node K will also involve with the computation of the companion node, which is K plus N divided by 2 raised to the power L. Alright, so if you look at this formula, the computation, let me say one more time, according to equation 17, it's a computation of the vector FL component K is given by the right hand side, which is the previous vector L minus 1 at the same location K plus W raised to the power P of the previous vector FL minus 1 at this location K plus N over 2 raised to power L. After we compute the value of FLK based on equation 17, then the companion node will be the computation of FL at this location. And as you can see, the location of node K and the companion node, they are different by the distance, which is equal to N divided by 2 raised to the power L. Now, if you compare the equation 17 and equation 18, that shows you the computation of FLK and the companion node, which is FL of K plus N divided by 2L. The computation almost the same. The only thing different is instead of plus the product, here you have minus the product. And that's why I keep saying to you many times, in real computation implementation, we calculate, let's say, FLK based on equation 17. And immediately after we get FLK, we should compute the companion node computation, which is shown in equation 18, simply by changing the plus sign to become the minus sign. So we just calculate basically FLK, and later on we can skip this companion node computation because the companion node you already computed immediately after you compute equation 17. Alright, Well, this is exactly what I just said to you earlier. In this slide, we're talking about skipping the computation of a certain node. Remember in the previous slide, I told you we always have the companion node, like a pair of nodes. If you're talking about node K, then the companion node of node K should be node K plus n divided by 2 raised to the power L. And the reason is because I told you many times, node K and the companion node in here, they are different by the distance, which is called n divided by 2 to the power L. So the idea is at the Lth level vector, after the computation of every n divided by 2 to the power L node computation, the next n over 2 to the power L node computation will be skipped. Figure 2, like I told you before. If you look at figure 2, or maybe one more time, okay? So, like for example, if you look at any level, I don't care level 1, L equal to 1, or level L equal to 2, or 3, or level L equal to 4. For example, if you look at level L equal to 3, and what it means is, according to the formula, the node K and the companion node of node K will be separated by the distance equal to the distance is equal to n divided by 2 raised to the power L. And so if level L is equal to 3, n equal to 16, then this ratio become 2. 16 divided by 8 is 2. And what it means is, in level L equal to 3, the way we do it is we compute, for example, the first 2 nodes, and then we will skip the next 2 nodes. And the reason we skip the next 2 nodes is because when we compute, let's say, F30, we can also at the same time compute F32. Instead of subtraction, and instead of adding, we subtract. And after we compute F31, immediately we compute F33. And that's why after we finish computation F30 and F31, we skip the next 2. And then we compute the next 2, and then we skip the next 2, and so on, so on, so on. Compute the next 2 and skip the next 2. Compute the next 2 and skip the next 2. That's the way it works when you write a computer program. Okay, so let's go back to my slides in here. We already discussed about that. See, so we just compute n over 2 to the power node, and then we skip the next n raised to the power divided by 2 to the power L node, like I just said to you in figure 2. And that is the end of this lecture. Here's the acknowledgement.